Hello everybody. I hope your quarantine is going well, but not so well that you don't watch this video. I hope your homework is going well. I definitely want to help with the homework as much as I can, and it seems like I've helped a few people. I know I'm only addressing 1 or 2 grade levels at a time. Just let me know in the comments if anybody's struggling with anything at any grade level, whether it's math, geometry, or even science, or reading, or history. Anything like that, I'd love to help out. But for now, I'm going to make videos about math. I love math, and I would love to transfer some of that love to whoever I can. Sometimes we have to do math. Math is very useful, so if I can help you enjoy it, I'm going to be very happy about that. So my most useful video so far has been the one on solving equations. So I want to touch on that more. I want to help people be able to solve equations more. There's definitely much more complicated equations that we need to solve that I need to go into. But first I need to talk about some tools that we're going to use. So today I'm going to talk about the distributive property. The distributive property is going to allow us to multiply a bunch of numbers by another number. So say we had 4 and we wanted to multiply, well, let's say we had 3 plus 5, and we want to multiply that sum by 4. So in the order of operations video, we learned how we can calculate what this expression is. And we need to do the addition first because it's inside of parentheses. So we do what's inside the parentheses first. So we would do 5 plus 3 is 8, and 8 times 4 is 32. So this expression is 32. I'm going to write this up here. But we can get around, well, yeah, we can calculate this in another way. We're not necessarily going to get around the order of operations, but we can take this 4 and move it inside of the parentheses. So if we just move it inside and multiply the 3, that's not going to work. 4 times 3 is 12. 12 plus 5 is 17. That's not the same answer we got. And if we just move it inside and put it with the 5, that's not going to work either. So when we use the order of operations, we turn this into 8 first, and then that 4 multiplied the 8, which means it was multiplying really the 3 and the 5 combined. It was multiplying both of those numbers, and that's what we're going to do. So the distributive property allows us to distribute the 4 amongst all of the members inside of this expression. So we distribute the 4 to the 3, which means we do 4 times 3, and then we add 4 times 5. So we have distributed the 4, this multiplication. 4 is multiplying everything in this sum. We've distributed the 4 to everybody in the sum. So 4 times 3 is 12, 4 times 5 is 20, and 20 plus 12 is 32. So now we get the same answer. So that is the distributive property. Why would we need to use this distributive property? Because sometimes we have in parentheses an expression that we cannot compute yet. Say we had 4 times 3 plus x. Okay, so the order of operations tells us do what's in the parentheses first, but what is 3 plus x? We don't know. We don't know what x is yet. We haven't solved for x yet, but sometimes we need to get this x away from this 3 or whatever. We'll go into why we might need to do this later, but as you can see here, we cannot do this addition right now. So the distributive property allows us to get rid of these parentheses by distributing the 4 to everybody inside. So 4 goes to the 3, we get 4 times 3, and we distribute it to the x. So we get 12 plus 4x. So this equals 12 plus 4x. And the distributive property works for any number, any amount of numbers in the sum. So let's say we had x times a plus b plus c plus d. So we've got a sum of 4 things. And then we want to take that sum and multiply the whole sum by a number, x, our favorite number. So it's easy. We just do a times x plus b times x plus c times x plus d times x. And we have distributed the x to everybody inside. So the distributive property here, it's a pattern. It's a mathematical pattern that we recognize as true, and every time we check it, we find out it's true again, it's true again. So if we have x times a plus b, which just means I have any number here, and then I'm multiplying it by the sum of 2 numbers. Could be 5 plus 7 times 114, doesn't matter. Whatever this number is, and whatever these ones are, this expression is equal to this expression. And it works in both ways. It works backward and forward. So, in other words, if I had an expression like w times b plus f times b, all right? I see that I'm multiplying b by all of the other letters, w and f. I'm multiplying b by everybody, so it's like b has already been distributed to a sum of w and f. So I can undo that distribution. And it's called factoring out. So when I do this in reverse, it's called factoring. Because all of these terms now in this sum, they both have a factor of b. So I'm going to take that factor out and get the sum w plus f. All right? So in this way, I've factored the b out, I've taken the b out of this sum, and that might be useful for some reason. When we're solving more equations, we're definitely going to see why this is so important. But for now, hopefully we can just recognize which steps I'm taking. So this is the distributive property. Let me give you an example with numbers, because sometimes letters just make everything more confusing. But in that case that I just showed you, I think the letters help to see that both terms in the sum had a factor of b. So now let's do it with numbers. Let's say I want to do 12 plus 16 equals. And I want to rewrite this using this expression. So I've got a sum here, and I'm not multiplying by anything. So I'm going to factor something out. Both of these numbers have a common factor. This number is 3 times 4, and this number is 4 times 4. So they both have a factor of 4. So I can rewrite these as 3 times 4, 4 times 4. Which means I can pull the factor of 4 out. Here when I was multiplying, I was multiplying. So when I'm factoring, I'm dividing. So 12, when I take away the 4, the factor of 4 out of the 12, when I divide that factor out, I've got 3 left. And when I take a factor of 4 out of 16, I have 4 left. So 16 plus 12, 16, 17, 18, 28. And this is 4 times 7. 7 times 4 is 28. So yes, this is working here. One more thing I'll touch on here. I could have taken a different factor out. So they do have a common factor of 4, but 4 is 2 times 2. So in other words, this guy has a factor of 2, and this guy has a factor of 2. So I could write this as 6 times 2, and I could write this as 8 times 2. And then I could take that factor of 2 out, get 2 times 6 plus 8. We can just check that. 16, 17, 18, 28. So this is 28 equals 2 times 8, 9, 10, 11, 12, 13, 14. So 2 times 14 is 28. Yep, works. So that's the distributive property. Let me know in the comments again if anything was unclear, if anything was confusing. Go ahead and watch the video again, or rewind when you need to, and see if you can get cleared up on anything. But let me know if I can help you out, and we'll use this when solving for x next time. Thanks.